Hi everyone, so this video we will talk about section 5.1, I think 5.1. We're gonna approximate area. Approximate area. So before we look into how to approximate area, we want to talk about the summation first. So what is summation? For example, if I have a list of the number and then I add them all up, so like the number 1 per 2 per 3 per 4 per 5 per so on until 100. Then you're gonna have a whole list of like 100 number, right? It's a lot. And instead of writing down all the number, we can also use the summation to represent that number. So it's gonna be the summation of k equal to 1 to how many number we have here. We have until 100. So k until 1 to 100, we call that this number is a variable and that variable is a k, start with 1. So this list of the number that adding to that the sum of all the number, and we can also call that a series, right? But in this section we're gonna say this is a summation. So the summation of k equal to 1 to 100 of the number k. So this will tell you that when k equal 1, I'm gonna have the first term. When k equal 2, I'm gonna add in 2. And then when k equal 3, we're gonna add 3. And we add until 100. So this is called summation. And if you have another summation, it looks like a M, right? An M, an horizontal M. So when k equal 1 to 20, 2k, then what did that mean? That means when k equal 1, your first term will be 2, because 2 times 1 is 2. And then your second term will be 2 times 2. Your third term will be 2 times 3 until you get 2 times 20. Okay, and in this section, we're gonna look through a formula that we can find this sum easily instead of list out all the number and add them by hand. Can we have a faster formula so that we can put into the formula and find out what is the sum is? Okay. And let's look at the property. The properties, one of the first property is actually work for this example as well. The first property say that if you have the summation of a constant coefficient times whatever the variable, you can always bring the coefficient to the front. And that is true because if you look at when I expand this summation, I have 2 times 1, 2 times 2, 2 times 3, 2 times 20, and all of the term will have the coefficient 2. So it means I can actually bring them to the front and write 1 per 2 per 3 per 4 per 220. Okay, so this will give you that is the coefficient is bring out. So I can have 2 times the summation of k equal 1 to 20 of k. Okay, so any coefficient that we can bring it to the front. And then the next property is saying that if you have the summation of two different terms, you can find the summation of individual term and then add them later on or subtract them later on. So for example, if I have summation of k equal 1 to 10, k plus k squared, then this will give you what? This will give you k, when I make k is 1, I have 1 plus 1 squared. My k is 2, I have 2 per 2 squared. My k is 3, I have 3 per 3 squared. And so on until 10 per 10 squared. Okay, instead of doing the summation together, we can consider putting all the 1 to 10 into k, and then adding all the 1 to 10 into k squared. So it means we can write that 1 per 2 per 3 per 10, and then add 1 square per 2 square per 3 square per 10 square. Okay, this will give you the same result because the addition have associated property. So we can break it into that, and this will same as k equal 1 to 10 of k plus k equal 1 to 10 of k squared. Okay, so that give you the second property. Now we're gonna look at the formula. How do we put in the formula to find out what is the sum of this quickly? The first formula we will have is the summation of a constant. If you have a summation of the constant, then that's gonna be equal to the constant term, how many number you want to go up to, okay? So for example, if I have k equal 1 to find a constant like 3, then isn't that when my k is 1, my first term is 3. When my k is 2, my first term is still 3, and my k is 3, my term is still 3, and 3 and 3. Okay, there's 1, 2, 3, 4, 5, because my k is go from 1 to 5. So I have 5 times of the 3. So this is same as 3 times 5. So that's why you have constant times n. So 3 times 5 will be the summation of a constant, which is 15. So if you have the summation of k equal 1 to 20 7, then you're going to have 7 times 20, which is 140. Okay, so that is the summation of constant. And then for the summation of the linear expression, which is k, summation of k. So according to the one above here, if I have the summation of k equal 1 to 10 of k, I will have 1 per 2 per 3 per 4 until 100, right? So but the result is saying that if you have the summation of k equal 1 to n of k, then that's gonna equal to n times n plus 1 over 2. Okay, we're gonna verify that with an example. So if I have the summation of k equal 1 to 5 of k, based on the formula, we will have n times n plus 1 over 2, which is, what is my n in this case? My n in this case is 5. N is 5. So we want to put into the formula, we have 5 times 5 plus 1 over 2, which is 5 times 6 over 2. And that gives you 15. Okay, and let's see if we expand this, does we get 15? So the summation of k equal 1 to 5 of k will be 1 per 2 per 3 per 4 per 5, and that actually gives you 15. Okay, so they are the same thing. So the formula is actually be derived using the arithmetic sequence. Okay, you will see that is actually the formula form. And then when summation is equal to k squared, not equal to k squared, summation of k squared, then that's going to be n times n plus 1 times 2n plus 1 over 6. And then summation of k cubed, you're going to have n squared times n plus 1 square over 4. Okay, so this is just the formula that you need to follow in order to find out the sum without putting all the number out and find out what the sum is. So let's find out what is the sum of this one. So I have k summation of k to the power 1, right? Then the formula say, oh, I will take n times n plus 1 over 2. And my n in this case 100 times 100 plus 1 over 2. And that will give you 50 times 101. And 50 times 100, 50 times 101, that is 5050. Okay, if you have a TI-84, you can also confirm your answer using the TI-84, where you go to math and then go to the summation down here, where you hit your math and then summation down here. And you will have we give you x equal 1 to n in this case 100, and then because we use the variable at x, so here will be x, and then we enter, we will have 50 50. Okay, so the summation from k to 100 of k is 50 50. Okay, so the formula is verified. So now we just use the formula to apply some example. You can try them and then compare the answer in the next video.